Hello and welcome to this video. My name is Aniruddha, call sign Victor Uniform number 3, Foxtrot Mike Lima. In this video, I'm going to talk about the homebrewed Allstar node I made using the Baofeng 888 and CM108 USB sound card with the Raspberry Pi 4 Model B. So what you see on the screen is the node that I'm talking about. Like I said, I'm using the Baofeng 888 radio as the node radio. It is quite cheap and very easily available, and it's quite okay for this project. The radio interface is this CM108 USB sound card, which you see here, which is interfaced with the Raspberry Pi 4 Model B. The power supply given is 12 volts, 3 ampere power supply, which is stepped down using this DC to DC buck converter to about 5 volts, which is required by the Raspberry Pi. And further, the same voltage is further reduced using a couple of diodes in series to get about 4.1, 4.2 volts, which is required by the Baofeng 888. So this is the basic setup here. And I'm using Baofeng UV5R as my handy to talk through this node uh, to the nodes that are connected. So for this project, there are certain modifications required for the Baofeng 888 as well as the CM108. So we'll look into each one of them separately. Let's start with the Baofeng 888 modification and some tips and tricks that you can do to make it work correctly. So this is the opened up Baofeng 888. The cover has been removed to expose this PCB. You see certain wires connected to certain points on the PCB. For example, this black wire is connected to the ground. This brown wire connected here is the 4.1 to 4.2 volts Baofeng power supply that we talked about earlier. The red wire is the PTT connected over here. This orange wire that you see coming from behind the PCB is the carrier operated squelch. So this is the back side of the PCB. Here you can see the wire coming from the pin number 1 connected to this IC. That is the carrier operated squelch. This yellow wire that is connected through a 10K resistor to this third terminal from the left of this volume port is the RX audio. Similarly, this green wire, which is again connected through a 10K resistor to the fifth solder pad from bottom. This is 1, 2, 3, 4, and this is the fifth one. This forms the TX audio. So these are the wires that are tapped from various points on the PCB of the Baofeng 888. So when you open up the Baofeng, there is a mic element over here. There is an electret mic element over here. Make sure to remove that, because when this radio goes into transmission, you don't want surrounding noises to get included in that transmission. So make sure to remove that mic element. If you see here, there is a golden colored ring nut. This nut is required to be removed when you are disassembling the Baofeng 888 for modification. Make sure to install it back when the modifications are done. This is because this ring nut forms a connection between the shield side of the antenna and the body of the Baofeng. So it provides a ground path. So make sure to install this ring nut back again. If you see the yellow wire, that is the RX audio, is connected to a point here, and these two are the speaker terminals. So make sure that you don't connect this yellow wire to the speaker terminals. In other words, don't try to tap the RX audio from the speaker terminals, because the level of that signal will be dependent on the volume knob. So if accidentally this volume knob gets turned, it's going to affect the levels of the RX audio, and you don't want that. And that's why this RX audio wire is connected to this terminal over here, which has no effect of turning off the volume knob. Let's talk about the settings of the Baofeng 888 as the node radio. Here I'm using the Chirp software to program the Baofeng 888. I've selected the frequency 434.555, and here under the tone mode you can see that I'm using DTCS, and the power I've selected is low. Earlier I started by using the CTCSS tone squelch, and I found out that maybe due to some kind of interference it used to get triggered randomly, and once the COS signal gets triggered because of the opening of the squelch of the node radio, your node is going to put out something onto the node that you're connected to. So when I'm using my handy, the UV5R, and speaking into it, the node radio is receiving those signals. It is opening up the squelch, and the COS line is getting triggered, and my voice signals are going through the node to the connected node. So if your COS gets triggered randomly because of some kind of interference, that is going to create a disturbance onto the node that you're connected to. And if you're connected to a repeater, it's going to be heard. That disturbance is going to be heard by other users, and you don't want that. So your COS should not get triggered randomly because of some kind of interference. And CTCSS was doing just that. It was getting triggered randomly. And so I shifted to a DTCS, and that worked fine. That worked reliably. So if you ask me, I would say that use DTCS instead of the CTCSS tone squelch. The other thing that you should do is disable the voice prompt. Here you can see the settings that I've made for the Baofeng 888. But the point I want to make here is that disable the voice prompts. Disable all this FM function, alarms, beeps, and battery saver, everything. The reason why you should disable the voice prompts is because the Baofeng gives out a voice prompt when you turn on the radio, or when the battery is low. And when that happens, the COS line gets triggered. So if you keep these settings enabled, those voice prompts would go over the network and they would be heard on the node on which you're connected to. So definitely disable this voice prompts and other things that are not necessary at all. So this is about the settings of the Baofeng 888 used as a node radio. If you see some of the procedures on the internet, you would see that many of them remove this component and this component on the PCB. This is the other side where we had interfaced the COS line. So these two components are removed to bring the Baofeng output from a couple of watts to milliwatts. But I have not done this modification. I've kept it as it is. And you saw earlier, I've kept the power level to low. Now, I don't know if this affects the Baofeng 888. Some say that it doesn't matter if it's high or low, it just outputs a couple of watts. But anyways, I've done the setting here and I have not done the modification here because I wanted to do as minimum as possible on the PCB itself. Let me talk about the antenna connections for the node. Now, most of the plans on the internet show that the node radio is connected to the rubber ducky antenna with a right angled SMA connector attached here. And I also did that. But I found out that there was a very high pitched whine in my received as well as transmitted signals. As I moved the antenna away from the node, that whine considerably reduced. And so I thought of then using the SO239 connector and connecting it with an external antenna. I have a ground plane antenna just outside my shack and it is far away from the node. And so it eliminated all kinds of high pitch whines that I was getting before. So I definitely would recommend to use the external antenna for this node. But if you wish to use the rubber ducky that comes with the Baofeng 888, make sure it is outside the box, away from the Raspberry Pi and the CM108. But I think you will still receive and transmit that high pitch whine to some extent. However, I also found out if you attach what we used to call as the tiger tail to the shield side of the rubber ducky antenna. So tiger tail is nothing but a piece of wire that connects to the shield connector. It basically provides the ground plane for the rubber ducky antenna. So if you attach the tiger tail to the rubber ducky antenna shield side, then I found out that the high pitched whine was completely eliminated. So if you want to use a rubber ducky antenna, experiment with this tiger tail. Also, what helps in reducing the RFI and the associated noises with it is if you use your handy, in my case, the UV5R, away from this node. So if I am at least 10 to 20 feet away from my node with the Baofeng UV5R on low power output, the RFI reduces and then you have a very clean signal. So if you are transmitting away from this node, it helps a lot. Also, if you see here, I have used the ferrite beads on all the connections. This is the connection between the Baofeng 888 and the CM108. So I've used a ferrite bead over there. This is the power supply for all the components. I've used a ferrite bead over here. If you see the LAN connector, I've used a ferrite bead over here. I've used a ferrite bead on the power supply. This is the main 12-volt power supply. So if you connect these ferrite beads, it should help. I don't know for what extent it will help, but I have installed them just to make sure that there is no other kind of interferences. Now let's talk about the ground connections. I'm giving 12 volts over here, and this buck converter is converting it to 5 volts. 5 volts are required by the Raspberry Pi, and then there is a series of diodes which convert it to 4.1 to 4.2 volts, which is being given as a power supply to the Baofeng 888. The CM108 gets the power from the Raspberry Pi itself. But there is a peculiar way in which the ground connections are made. And let me tell you why this is done. This is done to eliminate the ground loops, which would further eliminate any kinds of hum on your transmitted signal. So if you see closely, the power output of 5 volts, which are mostly the red wires, you can see that only the positive is given to the Raspberry Pi. The negative is not given here. The ground wire is soldered onto this USB. So each component will have its ground wire soldered one to one to this point. So for example, the ground wire of the buck converter is connected over here. The ground of the Baofeng is connected over here. The CM108 is already connected and the ground is connected to the same ground. And also the LEDs, which are here, the indicators, they have their ground connected to the same point. So each component has got its ground connection connected to the same point on the Raspberry Pi. And this is said to eliminate the ground loops and the associated hum interference on your signals. So this is how the grounding of the system is done, and it is quite effective. As I said earlier, we are using this buck converter to step down the volts from 12 volts to 5 volts, which is adjustable using this potentiometer over here. Now, that 5 volts is again reduced using a series of diodes. This also I said earlier, and that is done to bring that volts down to about 4.1 to 4.2 volts that this Baofeng uses. You can have a separate buck converter and you can adjust it to 4.1 to 4.2 volts and provide the power supply to Baofeng. That is also one way of doing it. But these buck converters are noisy and they can add that interference into this circuit. So it's better to use just one and reduce the voltage this way using a couple of diodes in series. The main thing is that keep this buck converter away from the Baofeng as much as possible in order to reduce any kind of interference. So let's talk about the modification of CM108. This is the most challenging part in this project because you have to deal with SMD components. And for someone like me who has very less experience and who is not so good at soldering, it's quite challenging. But if I've done it, you can do it also. There are a few tips and tricks that I would like to share, which will make your work a little bit easier. So let's talk a little bit about what all is required to be done. So if you see here, this is the allstarsetup.com website, which I'm referring to, which I have referred to make my note. Very well written instructions. Do definitely visit this, read about it, and you will get the confidence to make this node. Very, very well written. And I personally have followed the same instructions. So I'm giving the credit where it's due. Allstarsetup.com. I'm very much thankful to them for their instructions. So referring at one of the photographs shown here, let us talk about the modifications that are necessary to be done. So in this particular way of modifying the CM108, you need to first of all remove the the mic and the speaker connectors. So if you see, look here, there is the pink one and the green one, which needs to be removed. Then you need to remove a couple of components. So if you see here, this is the R6 resistor and the R7 resistor. These are basically the biasing resistors for the mic connections. So some mics require power supply to be given to them, but in this case we don't require that. So we have to remove these biasing resistors. You have to remove the C2 capacitor over here. And from what I read, this will carry the COS connection. And I think that there is a DC component on the signal that is tapped for the COS. There is a DC component in that, and that is used to detect the COS. And if this capacitor is present, then it will block that. And to remove that um, DC blocking, we have to remove this capacitor. At least that is what I remember. Maybe I'm wrong. If anyone knows better, then please put it in the comments. I will also learn from that. But basically, the COS signal that we are tapping contains a DC level included in that, and that level is being detected as the COS. And if this capacitor is present, then that DC gets blocked. And so to eliminate that, we remove this capacitor. This is what I understood, but maybe I'm wrong. You can put the correct thing in the description. So okay, so basically we need to remove these two biasing resistors and this capacitor, and then we need to make two connections. This is the COS connection, that is from pin 48. That's the last one on this side, and it goes to this particular terminal of the C2. And then this pin number 13 of this IC, it is again at the corner. That is the PTT, which goes and gets soldered over here. And then this is the PTT line which goes to the Baofeng 888 that we saw earlier. This is the RX audio. If you remember from earlier discussion, it it gets connected over here from the Baofeng. This is the TX audio of the Baofeng 888. There it was green in color, so it gets attached here. This is the COS cable. In our case, it was orange colored cable. So maybe I can show you my version of it, but this was giving better clarity, so I chose to show that. But here you can see the R6 and the R7 being removed. The C2 capacitor is removed. 48 number pin gets connected here. This is the COS. The 13 number gets connected here. This is the PTT. The PTT from the Baofeng, that was the red in color, gets attached to the same point. This is the green colored wire from the Baofeng, that was the TX audio, gets connected to the speaker terminal on this connector. And then this is the orange wire which came from the backside of the PCP, that is the COS. And then there is this 1K resistor that is added between these two terminals. This black wire is for the PTT LED in front of the enclosure. So all these instructions about making this are there on this website. Do check it out. Very simple to follow instructions. But the point I was trying to make here is to give some tips and tricks about the modification so that you won't go wrong and ruin your CM108 sound card. Although it is cheap, at least in India, it's not available and we have to import it. So you can learn from my experiences. I have wasted one of them trying to do the modification, but then I came to know how it could be done effectively. So let's get to those points first. The first thing is to remove these connectors. Now, do not use solder gun and try to remove these connectors, because these solder pads are very very delicate, and if you apply too much heat they get uprooted and you will just lose that connection. What they recommend is to use a hot air blower with preferably a narrow nozzle to safely remove this. So they say that if you apply the heat through the blower, they just float away and you have very clean connections. I didn't have that. So I was thinking of ways that I can do it without damaging these solder pads or the tracks. So what I did was I used a Dremel tool with the rotary attachment attached to it, and I just cut this thing in half. These metal connectors, I just cut them in half. So these things go on either side and they get attached to the solder pads. I cut them in half. So now I had two different parts. I gently removed the metal away from the connector, and then the connector was free to be removed. Then I used precision cutting pliers and cut these remaining uh, metal parts. If some of them are left, just leave them. It's no big deal. If you see here, you can see that some of the parts are left. It doesn't matter. You can solder things to it, so it should not matter. But this is how I've done, and I found it to be quite easy, and it will make sure that none of these solder pads get damaged or none of the tracks get damaged. So this was the main point regarding removing these connectors for the further modifications to be made. As far as are these R6 and the R7 resistors are concerned, if you apply heat to one end and just lift it, they will float away. No problem at all in removing these two as well as this one. That is not a problem at all. Um, if you see here, the connectors, the pins to which the COS and the PTT lines are connected, they are at the corners. So you have nothing on this side and this side, and you can easily solder them. People think that this is the most difficult part, but I think that removing the connectors is the uh, most difficult part. Here, when you want to solder, use the smallest gauge wire that is possible. Use a magnifier to look before you solder or while you solder, and make sure you use the most thinnest uh, tip, soldering tip, onto the solder gun. Do not use any solder metal onto the tip. Just tin these wires, and then using heat, just touch them for a couple of seconds, and that connection should be good. So yeah, definitely follow the procedure that is given on this website. I did the same, but these are few things that I wanted to share about removing the connectors and how to connect these things. The next point is that try to install a cooling fan for the enclosure. And there is a good reason for it. Normally, when we are using a VHF or UHF radio, or any kind of radio, really, we receive for most of the time, and the transmission time is less comparative to it. So there is not that much of an heating issue. But here, when you are receiving from the node, from the network, your Baofeng 888 is going to transmit, which you are going to receive on your handheld Baofeng UV5R. So that means that you are receiving for most of the time, and that means that your Baofeng is going to be in transmit. The Baofeng 888, the node radio, is going to be in transmit most of the time. So the transmission duty cycle is quite higher, and it's going to produce some heat. And so it's better to have a cooling fan installed. I'm using this cooling fan. It is a simple USB cooling fan, quite silent, and it circulates air. It is connected to the Raspberry Pi USB port itself. And good thing is that it is not giving any kind of interference. So it is mostly pulling the air inside the enclosure. And I have some of these open spaces. The air, hot air comes out from the back. So yeah, try to install a cooling fan because your Baofeng 888 is going to be in transmit for most of the time when you are receiving on your Baofeng UV5R. And the last tip that I can give you is that when you want to switch off this node, don't just switch off from the switch. Do what we call as gracefully shut down the Raspberry Pi. This we need to do so that your SD card does not get corrupt. So there are a couple of ways in which you can gracefully shut down the Raspberry Pi. You can find it on the website that I showed earlier, and also on hamvoip.org, that they have given a procedure how to connect a momentary switch to some of the pins. I don't remember exactly which pin, but if you connect a momentary switch to those pins, the software already has got it programmed in it. And if you just hold that momentary switch closed for a few seconds, it is programmed to switch down or shut down gracefully. How I do it is a bit different, and let me quickly find out if I can show you that. If you go to the hamvoip.org, and if you go to the how to section and Allstar functions, I think it's this one. And if you scroll down, where is it? So by pressing star B1, you can shut down the system. Yeah, here it is. You have to remove this semicolon in the rpd.com file, which is in the etc asterisk folders, and you scroll down to the place. Where did it go? Here you remove the semicolon, and this will activate this command. So B1. So if I press the PTT on my Baofeng UV5R, if I press the PTT and enter star B1 as DTMF command, the system will shut down on its own. It is important to shut down the system gracefully so that none of the things get corrupt. So this is all I wanted to share. Keep this thing in mind when you are making the node. It will eliminate most of your problems. Thank you very much for watching this video, and thank you very much for watching all my other videos. If you have not subscribed to my channel, I request you to please do so, and share this video and give it a thumbs up if you have liked it. Do subscribe. Thank you very much, and until next time, this is Victor Uniform number 3 Foxtrot Mike Lima saying 73s.
To you, Don, and come on in. And I hope that everything is A-OK there where you are. Everything is A-OK. I'm mobile It's Friday, so you know it's fish and chip day. So I'm heading off. I'm leaving a little late, but I had a couple errands to do. I hope everybody has a interesting long weekend. All the best to all the kids heading back to school. We were on the highway yesterday, and there were lots of trailers and rental vans and cars packed full of stuff at the en routes. It's an exciting weekend. My granddaughter starts school. She moves in tomorrow, so it's going to be an interesting year. Anyway, everybody have a great day. I'll be one and done, Bob. I'll be on the road. 73